Sorry about that, guys. Now I have to split this into two videos. Okay, so the total potential difference is 20 volts. The total current, that's what we're looking for. Okay, and the total resistance is 4 ohms. So to get I total alone, we divide both sides by 4, and we find that the total current is 5 amps. So we've got a total of 5 amps flowing through this circuit. Okay, so we've got 5 amps coming out of the battery, 5 amps, 5 amps. Those 5 amps split. We don't know in what ratio, but they split. Okay, then they come back together here, so we've got 5 amps going through bulb 1. Okay, let's look at question 2. We need to determine the potential difference of the parallel combination. Okay. Oh, that's not so hard. Okay, so remember when you're dealing with a parallel part or a parallel circuit or a parallel section of a circuit, that the potential difference in each branch is the same, and that is the same as the total potential difference for the parallel section. So they told us that the potential difference in this branch here where bulb 2 is, they told us that that was 10 volts. So we know that this branch is 10 volts and this branch is 10 volts and the whole thing is 10 volts. Okay, so we're just going straight into using the fact that we know how potential difference works in a parallel circuit. Okay, so we're going to say that V parallel equals to V in each branch, and we know the potential difference in that top branch is 10 volts. Done. Okay, question 3, determine the potential difference over bulb 1. So that's this guy here. Okay, so again, we can either use Ohm's law or we can use our understanding of potential difference in a circuit. So let's check for Ohm's law. I don't know its resistance. I do know its current though, right? We worked out that the total current is 5 amps. So the current through bulb 1 must be 5 amps. And I'm looking for potential difference. So unfortunately, I don't have enough information because I don't know that bulb's resistance. So I've got to use my understanding of potential difference in a combination circuit. So in a combination circuit, the total potential difference is equal to the parallel plus the series potential differences. So we can substitute in now. We know the total potential is 20 volts. We know that the potential difference over the parallel section is 10. And we are looking for the potential difference over bulb 1. Okay, so easy to solve. We can now say V of the series section, which is basically just the potential difference of bulb 1, because that's the only series resistor. That is going to be equal to, what is it, 10 volts. Okay, and that's it again. Okay, question 4. The resistance of bulb 1. Okay, now we can use Ohm's law. Remember, we couldn't use Ohm's law here because we only knew the current. To use Ohm's law, you need 2 of the 3 things. Okay, so we couldn't use it for this question because we only had current. But now we've just worked out potential difference, so now we know 2 of the 3 things there, and we're looking for the third. So we can use the fact that V equals IR, the potential difference is 10, the current is 5, and we are looking for the resistance. Okay, so we divide both sides by 5, and we get that the resistance of bulb 1 is 2 ohms. Okay, then question 5, this one's a little bit trickier, so we need to determine the resistance on bulbs 2 and 3. Okay, so we can either use Ohm's law, so let's look for bulb 2. I know the potential difference. I do not know the current, right? We don't know how the current is split. We know we've got 5 amps, but we don't know how many of those 5 amps have gone this way. And we also don't know its resistance, so we can't use Ohm's law. So let's go ahead and see, can we use our understanding of how resistance works in a combination circuit. So in a combination circuit, the total resistance is equal to the parallel plus the series resistance. Is this going to help us? We know the total resistance, we know the series resistance, we just worked it out, it's 2 ohms. And the parallel resistance is a combination of bulb 2 and bulb 3. So this is going to help us. Okay, so we've got to expand this. Our total equals our parallel. I've got 2 branches there, and in each branch I only have 1 resistor. So I can say this is going to be the resistance, that was going to be the sum of 1 over the resistance of bulb 2 plus 1 over the resistance of bulb 3 to the minus 1. Always remember to raise to the minus 1 to get it from 1 over Rp to Rp. And then plus our series resistor, which is bulb 1, which is 2 ohms. Okay, but let's just call it R1. We haven't subbed in yet. Okay, now we're going to substitute in. So the total resistance is 4 ohms. Okay, R2, they told us, or the bulb 2, they told us has a resistance of R. And bulb 3, they told us has a resistance of 2R in the question. And then resistor 1 has a resistance of 2 ohms. We just worked that out. Okay, now we just have to solve for R, which I know might seem a little bit easier said than done. So first thing I'm going to do is hop this 2 over and subtract it. It makes life a little bit easier. Okay, now in here I'm adding 2 fractions. So we need to think back to grade 8 and think, how would I add 2 fractions like this? I need to have the same denominator, right? So in order to get these to the same denominator, do you agree my LCD needs to be 2R? Because I've got 1R and 2R. So my LCD needs to be 2R. So to get these to both have a denominator of 2R, I need to multiply by 2 at the top and the bottom of that fraction. Okay, so then I'm going to have 2R at the bottom, and at the top, 2 plus 1. Okay, so let's go ahead and add those. That means 2 is equal to 3 over 2R to the minus 1. And now remember, to the minus 1 just means invert it. Okay, so now we can invert it. Notice I waited until I had a single fraction before I inverted. Very important in life in general, in maths especially. If you have 2 fractions, okay, and you want to invert them, you cannot say that that is equal to x plus y. Please, you have to turn it into 1 fraction before you invert. Got it? Okay. So looking back here, we turned it from the 2 fractions into 1 fraction. Now we're going to invert it. So now we're going to say that means that 2 equals 2r over 3. Okay, and now that should be quite easy to solve. Okay, I'm just going to move up to here because I'm running out of space. So that means 6 equals 2r, which means that r is equal to 3 ohms. So the resistance on bulb 2 is 3 ohms. Okay, so this is for bulb 2. The resistance on bulb 3 then is twice that, which is 6 ohms. Okay, so I know this one got a little bit scary. This is quite a high order question. This is more something that you would see in grade 11 than in grade 10. Not to say that this has definitely been asked in grade 10, but it's very unlikely. Yeah, it's more likely you're going to see sort of things like this in grade 10. This video is also actually going to the grade 11s as revision. So yeah, you guys will definitely see things more like this, grade 11s. Okay, yeah, that's it. I know it's a little bit scary. I will definitely have a look on YouTube to see for any more resources, any other videos explaining combination circuits. The problem just comes in that the symbols that they use in America are different to the symbols we use here. So don't get confused with the symbols if you look at other videos, especially Khan Academy is really good, but they use different symbols for resistors especially. Yeah, okay, I'm going to leave you there. Please do let me know if you get stuck, ask for help. We need to be communicating a little bit more with each other, please.